Triangles are the simplest of polygons, which make them relatively easy to learn about. It is important to learn the coordinates of the special points like vertices, midpoints of sides, centroid, orthocenter, incenter, circumcenter, etc. in a triangle. This video talks about some of these points and finding their coordinates using section formula. You might have already seen the section formula for internal and external division of a line segment. That is, if R, X, Y, Z divides the line segment PQ with endpoints P, X1, Y1, Z1 and Q, X2, Y2, Z2 in the ratio M is to N, then for internal division, the coordinates of R would be mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n, mz2 plus nz1 divided by m plus n. For external division, the coordinates of R would be mx2 minus nx1 divided by m minus n, my2 minus ny1 divided by m minus n, mz2 minus nz1 divided by m minus n. Now, in the internal division, what if m is equal to n? That is, point R divides the line segment PQ into two congruent line segments, which means R would be the midpoint of PQ. So, m is to n is equal to 1 is to 1. Then the formula to find the coordinates of R becomes x is equal to x1 plus x2 by 2, y is equal to y1 plus y2 by 2, and z is equal to z1 plus z2 by 2. This is called the midpoint formula in three-dimensional geometry. Let us apply this to a problem. If 2, 1, minus 1, 0, 1, minus 1, and 1, 0, 2 are the coordinates of the midpoints of the sides of a triangle, what are the coordinates of its vertices? Let the triangle ABC with the coordinates A, x1, y1, z1, B, x2, y2, z2, and C, x3, y3, z3 has these points as the midpoints of its sides AB, BC, and AC respectively. Then, according to the midpoint formula, we have x1 plus x2 by 2 is equal to 2, y1 plus y2 by 2 is equal to 1, z1 plus z2 by 2 is equal to minus 1. Or x1 plus x2 is equal to 4, y1 plus y2 is equal to 2, z1 plus z2 is equal to minus 2. In a similar way,
Hey Google,
we can write two more sets of equations for the sides BC and AC as x2 plus x3 is equal to 0, y2 plus y3 is equal to 2, z2 plus z3 is equal to minus 2, and x1 plus x3 is equal to 2, y1 plus y3 is equal to 0, z1 plus z3 is equal to 4. To solve these equations, to find the coordinates of the vertices of the triangle, first add the respective x coordinates, y coordinates, and z coordinates. So we have x1 plus x2 plus x3 is equal to 3, y1 plus y2 plus y3 is equal to 2, and z1 plus z2 plus z3 is equal to 0. But we already have x2 plus x3 as 0, so x1 is equal to 3 minus 0, that is 3. Similarly, we have y2 plus y3 as 2. So y1 is equal to 2 minus 2, that is 0. Also, z2 plus z3 as minus 2. So z1 is equal to 0 minus minus 2, that is 2. Now, using the values of x1 in the equation, x1 plus x2 is equal to 4, x2 is equal to 1, and since x1 plus x3 is 2, x3 is equal to minus 1. Similarly, y2 is equal to 2, y3 is equal to 0, and z2 is equal to minus 4. And z3 is equal to 2. While a midpoint bisects a line segment, it is possible to find the coordinates of the points if we trisect a line segment. Let us start with the line segment P, x1, y1, z1, and Q, x2, y2, z2, and the points R and S divide the segment PQ into 3 equal parts. Then the ratio with which the line segment is divided is 1 is to 1 is to 1. It is clear that the point R divides the line segment PQ in the ratio 1 is to 2, and the point S divides the line segment PQ in the ratio 2 is to 1. So applying the section formula for n is equal to 1 and n is equal to 2, the coordinates of R would be x2 plus 2x1, the whole divided by 3, comma, y2 plus 2y1, the whole divided by 3, comma, z2 plus 2z1, the whole divided by 3. In a similar way, the coordinates of the point S can be calculated by applying the section formula for m is equal to 2 and n is equal to 1 as 2x2 plus x1, the whole divided by 3, comma, 2y2 plus y1, the whole divided by 3, comma, 2z2 plus z1, the whole divided by 3. Now, the medians of a triangle connect the midpoint of each side to the opposite vertex. The point of intersection of the 3 medians of a triangle is called the centroid. The centroid divides each median in the ratio 2 is to 1. Now, since D is the midpoint of the side AB, the coordinates of D can be written using the midpoint formula as x1 plus x2 by 2 comma y1 plus y2 by 2 comma z1 plus z2 by 2. Now, point G divides the line segment CD in the ratio 2 is to 1. So the coordinates of point G is given by the section formula as x plus 2 times x1 plus x2 by 2, the whole divided by 3 comma y3 plus 2 times y1 plus y2 by 2, the whole divided by 3 comma z3 plus 2 times z1 plus z2 by 2, the whole divided by 3. This can be simplified to find the coordinates of the centroid as x1 plus x2 plus x3, the whole divided by 3, comma, y1 plus y2 plus y3, the whole divided by 3, comma, z1 plus z2 plus z3, the whole divided by 3. Further, if we know the coordinates of two vertices and the centroid of a triangle, we can use this expression to find the coordinates of the third vertex. For example, the coordinates of the centroid of triangle PQR with two vertices P 4, 1, -3 and R 2, -5, 0 are G 3, -2, 0. What are the coordinates of the third vertex Q? Let the coordinates of the third vertex be Q, X, Y, Z. We already have the expression for the coordinates of the centroid. Substituting for the coordinates of the other two vertex and the centroid, 3, -2, 0 is equal to 4 plus 2 plus x by 3, 1 plus -5 plus y by 3, -3 plus 0 plus z by 3. Equating the corresponding coordinates, 4 plus 2 plus x by 3 is equal to 3. That is, x is equal to 3. 1 plus -5 plus y by 3 is equal to -2. That is, y is equal to -2. -3 plus 0 plus z by 3 is equal to 0. That is, z is equal to 3. Let us summarize what we've just learned. We learned the midpoint formula as an application of the section formula of internal division when m is to n is 1:1. That is, if r is the midpoint of PQ, then the coordinates of r are x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. We applied the midpoint formula to find the vertices of a triangle if the coordinates of the midpoints of the sides are given. Going further, we learned that points of trisection of a line segment would divide the line in the ratio 1:2 or 2:1. We also derived an expression for the coordinates of the centroid of a triangle based on the fact that the centroid divides each median in the ratio 2:1. The coordinates of the centroid for a triangle with vertices A, x1, y1, z1, B, x2, y2, z2, and C, x3, y3, z3 are given by x1 plus x2 plus x3, the whole divided by 3, y1 plus y2 plus y3, the whole divided by 3, z1 plus z2 plus z3, the whole divided by 3. Now that was about the application of the section formula for internal division. Now, just as the opposite of the midpoint formula, can we derive the coordinates of a line segment that is double the length of the given segment by substituting m is equal to n is equal to 1 in the section formula for external division? That would result in a 0 in the denominator. Where did we go wrong? For external division, m corresponds to the total length of the extended line segment, and n the length between the endpoint of the given segment and the external point. So, how can you find the coordinates of the point R such that the length PR is double the length PQ? Try it out for yourself. Keep watching for more